Hello everyone. Today I will be talking about SEM, the Scanning Electron Microscope. SEM uses electrons instead of light particles, but why use electrons? According to de Broglie's wave theory, wavelength and the electron speed is inversely proportional. This means that the faster the speed, the shorter the wavelength. To magnify a sample to the highest extent, the penetration ratio must be high. The penetration ratio can be thought of as a resolution on a television screen. This ratio can be raised by shortening the wavelength of light. However, the wavelength of light visible to us is limited to 400 to 700 nanometers, which means there is a limit to magnifying. But when you use electrons as a light source, you can accelerate it so that it would have an even shorter wavelength than the visible light. This is why we use electron microscopes, to magnify further. You may wonder, how do you accelerate an electron though? Well, it uses magnetic and electric fields to accelerate. By using Lorenz's force to create a circular motion of the electron, and alternating the electric field to speed up the electron, it is possible to accelerate them. Now, how do you use SEM? First, we need to verify whether the observation target is metal or non-metal. If it's a non-metal, you need to sputter a type of metal, namely gold, to the target. I'm going to use an ion sputter coater. It is used as a pre-processing apparatus to obtain sharp SEM images. The purpose of this coater is to increase the quantity of secondary electrons released from the sample. This coater coats on a thin layer of gold using plasma, as shown here. The gold acts as a sort of catalyst, I suppose. Secondary electrons are free electrons that get loose after receiving energy from colliding with a primary electron. This process is very similar to the photoelectric effect, which uses light as the energy source that electrons absorb. After readying your sample, we are now ready to put the sample into SEM. Go ahead and open the vacuum control program and click the vent button. This will raise the pressure within the chamber so that you can open it. When putting the sample onto the chamber, use a screwdriver to firmly lock the sample in place. You can turn the R button to rotate and adjust the position of the nail hole, and tilt the T button to position your sample more easily. After that, close the chamber and press vacuum. When observing a sample, there can't be any impediments, not even air, so the machine checks whether or not the chamber is in a vacuum state. If not, it won't let you observe at all. When the chamber is in a vacuum state, press the Program Open button and finally start monitoring. When you're on the main menu, click the High Voltage button. Now move by pressing the Image Shift button and hold your right mouse button on where you wish to move. Zoom in and out by pressing the magnifying glass icon and scroll with your mouse wheel. When your image is zoomed in quite a lot, it's easier to adjust your movements by hand using the X and Y knob rather than positioning via program. Also, adjust the focus and stigmator by using the mouse wheel as well. A little tip on adjusting the stigmator and focus is when the stigmator is off, try to find a curved edge on your sample and adjust the focus to find a point where your image doesn't look distorted. When the focus is off, adjust the stigmator to find a point that is most clear and sharp. Thank you for watching and have a nice day.